All right, the problem one got it. Answers. So if you took those numbers, typed them into your list on your calculator, it should tell you that the standard deviation, this funky looking O with an X, is 10.7. Okay? If you square that, that'll give you the variance. So this is your standard deviation, the variance is 115.14, looks like. So it shouldn't take that much time. You type it in your calculator, let the calculator do all the work. Now, finding the standard deviation, as easy as it is, that's not where it stops. You don't just find a standard deviation. You use it to compare one data set to another data set. For example, the problem one got it had a standard deviation of 10.7. The example that we were working on just a few minutes ago had a standard deviation of 1.5. Well, how do you compare the two standard deviations? What does it mean? Well, the example problem we did had a really low standard deviation, and remember, these are measures of spread. So the lower or the smaller the standard deviation, the more close together the data points are to the average, or it's not quite as spread out. With a higher standard deviation, like 10.7, the more spread out the data is from the middle. So that's one comparison you can make. Another thing you can do with just one set of data, you need to write this phrase here. In any particular data set or list of numbers, every value falls within some number of standard deviations of the mean or of the average. In a data list, every value on that list falls within some number of standard deviations of the mean. So quickly finish writing that up. Every value falls within some number of standard deviations of the average. And here's what it means. Let's go back to the example that we've already done. So just these 5 numbers right here, we calculated that the average was 7.4. So I'm going to write that up here. 7.4. Now the standard deviation, let's see, was 1.5. So if we figure out how far the standard deviation is from 7.4 on either direction. So if you add 1.5 to 7.4, let's see, 1.5 to 7.4, we get 8.9. If we subtract 1.5 from 7.4, so 7.4 minus 1.5, we get 5.9. It went in the other direction, we've got 5.9. So one standard deviation of the average for this set of data would be between 8.9 and 5.9. So if you look at our list here of 5 numbers, does every single number on this list fall within one standard deviation of the average or of the mean, 7.4? And the answer is no. We have this number right here, 9.0. It doesn't fall within one standard deviation. So we need to go one more standard deviation. So if we add another and subtract another 1.5 on either side, so I'm going to now start with 8.9 and add one more standard deviation of 1.5. That gives me to 10.4. And then if I subtract another 1.5 from 5.9, that's 4.4. 4.4. So now we're at 2 standard deviations away of of the mean. So we're from 4.4 to 10.4. Does that encompass every single number in our data list? And the answer is yes. So the question here for example 1 would be, how many standards, or within how many standard deviations do all of the data points lie? And in this case it would be 2 standard deviations. It takes 2 standard deviations to encompass all of these numbers. So something you need to write down here. In general, approximately 60% of all data in any list falls within 1 standard deviation. Approximately 95% would fall within 2 standard deviations, and approximately 99% would fall within 3 standard deviations. I'll give you a second to write that. You know, with this first part here, 68% of the data, that's almost 3/4. 3/4 of all data in any data set would fall within 1 standard deviation. And this is kind of getting a little bit ahead into one of the other lessons, but this is called normally distributed data. We'll talk about that later on down the road, but if the data is distributed normally, then this generally applies to the data. So what you need to do here, a line, in the middle of that line, put a dotted right in the middle of it, and we're going to say this is the mean. Average. Usually the average is right towards the middle, so we're going to put the average right there in the middle. Okay. Now from here to here, let's say that that's a distance. Actually, we'll put this underneath. So from here to here, that's a distance of a standard deviation. So that's 1 standard deviation away from the average on either side. There's another standard deviation and a third. So all of these distances represent standard deviations. So right now I've got 3 standard deviations from the mean, or of the mean. So according to this, if we had some kind of data, 68% of that data would be within 1 standard deviation. Now we don't have actual numbers here, so to represent data I'm going to use x's. 68% of the x's would be within 1 standard deviation, so we're going to draw a bunch of x's here. These are just data points. Okay. And this is the bulk of them, and notice they're within 1 standard deviation. They're closely clumped around the average. Okay. But that doesn't encompass all of the data, only 3/4, or about 3/4, 68%. So there's going to be some of the data that lies within 2 standard deviations. So we have to have some of the data here. And even that doesn't encompass all of the data. Sometimes in data sets, you have to use 99% of data fall within 3 standard deviations. So we have to have a few data points there. And this kind of a shape for if data is distributed in this way. This is called normally distributed data. It follows what's called a bell curve, like this, or approximately. We'll talk about this a little later on in the unit, but this is what it's talking about. Most of the data falls right here within 1 standard deviation. Some of it spills over to 2 standard deviations, but almost all the data can be fit into 3 standard deviations. Okay. So, this is an example of what you're going to see in your homework. We've got, from the U.S. Weather Service, we have the number of hurricanes that have struck land from 1851 to the year 2000. So it's a 150-year time span. It's a lot of hurricanes that have happened since then. So to organize the data, they've broken it into decades. And I've got a table of values here that shows the number of hurricanes in any particular decade since the year 1851. So decade 1 would mean the first decade, 1851 to 1860. Decade 2 would be 1861 to 1870, and so on and so on. So we've got 15 of those decades, so make that list there. 1, 2, 3, 4, 5, all the way up to 15. And then underneath that, we've got the number of strikes that occurred within that decade. So I'll give you a second here to copy this table down. Once you've got these numbers written down, we need to find this and that. Remember, this is the mean, this is the standard deviation. So, calculator out, type these numbers here, 19, 15, 20. This is not, remember, this is not a frequency table, so it's not that the number 8 occurs 13 times, or the number 13 occurs 8 times. This is not the same as a frequency table. And this just tells you what decade you're in. So these are the numbers you're going to be typing in right here into your list on a calculator. 19, 15, 20, 22, 21. So give you a second to type those in. Okay, so I've got the numbers typed in. Hopefully you've had enough time to type them in. It shouldn't take you that long. Once you got it typed in, go back to stat, calculate one variable statistics. I'm getting an average of 17.2 and a standard deviation of 3.67, I'm going to call that 3.7. Okay, so here's the question you would have to answer on your homework for a question like this. Within how many standard deviations of the mean do all of the data points lie? So we've got the mean right here. This is just like what I showed you a few minutes ago. We've got the average of 17.2. If we add and subtract on either side one of the standard deviations, so we started 17.2 and add 3.7, that's going to be 20.9. And then on the other side you subtract 3.7, so 17.2 subtract 3.7, that's 13.5. So do all of the data points fit within one standard deviation between 13.5 and 12 and 20.9? The answer is no. We've got a 24 right here. We've got so we got a 12 over here. There was a 21 and a 22. So all of the data doesn't fit within one standard deviation. So we need to do another standard deviation. So if we add and subtract another 3.7. We got 20.9 plus 3.7. That's 24.6. And then we need 13.5 minus 3.7. And that's 9.8. So between 9.8 and 24.6, does that encompass all of the data points? And there's nothing higher than 24. There's nothing smaller than 12. So all of the data points in this table would lie within two standard deviations. This is how you would answer that question. And that's it. That's pretty much what you would need to know here for finishing your assignment.